Okay, so you are going to be talking about factors and products, but we're also going to start talking about prime numbers. Okay? Most of you did a nice job on your factors and products on the test, so we're going to kind of be on it. So just really quickly, what I want you to do is in a sentence, Carter, do you have a to write? Okay, you need to get a piece of paper and a pencil. We don't do this on the iPad. Yep. For those of you that are still over here, you are going to write 3 things in sentences. Okay, so I think that. The first one, write what a factor is and give me an example. The second one, write what you think a product is and give me an example. And the third number is write what you think a prime number is and give me an example. Ask Jake.
I could just help her.
Any of these guys right here have been doing it. The first one is what you think a factor is and an example. The second is what you think a product is, an example. And the third one is what you think a prime number is, and an example. Some of you have already done Ferrier models on some of these, so they're probably going to be pretty easy.
I'll just say the one right with
Yep. So factor, product, and prime number. Yeah, just write maybe one example, just to show me that you understand what it is, and you can do that through an equation, you can do that through factoring. Okay.
If they need something, just
I can tell you. I appreciate it. So you're going to write what you think a factor is, what you think a product is, and what you think a prime number is. So really quick definition, and give me an example of each of them. Then I'll give you guys about a minute to write. Ask someone to borrow some. Mine's put away. So someone from this group might be able to rip one out.
yeah. I borrow so they can play.
Well, 30 more seconds to write. You are writing what you think a factor is, what you think a product is, and what you think a prime number is. What you guys want to get here?
I need one.
Okay. An example of. Okay. Can someone tell me what they think a factor is? Yes.
What do you mean, hurry up?
I'll just say to get a result. Okay, and someone give me an example of a factor. Yes. Yep. We'll stay with factor really quickly. Drew, do you have an example of a factor? That's fine. Okay, so this is one example of factors. Okay, I'm going to kind of point you in a direction here. So if I were to write 6 times 4 equals 24, where are my factors going to be? Yes. 6 and 4. Okay, so I'm going to write an F underneath those. And for the next day or two, I would like you to write an F underneath the factors and things, just so you remember in your head, it's a mental note where those are. Okay? Yes, go ahead and give me a definition for product. What's that? Answer to multiplication product. Okay, someone give me an example of a product. Yes. Okay, so product. And that's definitely one way you can do it. What I'm going to ask you to do, in 6 times 4, what's the product? 24. So what I'd like you to do is write a P. You don't have to, if it's easier for you to circle products and put squares around factors, that's fine. Make sure you can differentiate them. But just know some way in your head that you're able to tell that these are factors and that's a product. And just for the next couple days. After that, you should have it down in your head that you know where factors and products are, and it's going to be very easy. Okay? So what I'm going to do before we get into prime numbers is I'm going to read you a word problem, and I want you to write the word problem, answer the word problem, and then set it up like this. So you get factors, and products. Okay? So, the question is, and this might take you a little while to do some math, more of a complicated question. If there are 28 students in our classroom, and a parent makes 6 cookies for each student to bring home, how many cookies would be needed in total? So there are 28 students, and each of them are going to get 6 cookies. How many cookies do I need to make in total?
I want you to go to 5.
The other one is boring, but if it's more factors.
I'll give you just a minute to figure it
out. Okay, no, 5. My neighbor.
out. Use whatever strategy works best for you in solving the problem. Give you about 30 seconds. Carter, what are we working on? Prayer? Okay, good. All right, would someone who I haven't really heard yet like to share their answer? Go ahead. Okay. If you agree, thumb up. If you disagree, thumb down. If you're not sure, thumb in the middle. Wonderful. That is great to see. All right, let's move on then. Factors and products. Actually, one quick question. Can you have more than 2 factors in a problem? All the ones we focused on are going to have 2 factors. Can you have more than 2? Okay, someone give me an example of a problem. Yes. Good catch. Okay, 2 times 2 times 2. Meat. Okay, so where are my factors? 2, 2, 2. So I'm going to put an F underneath those. And where does my P go? 8. Wonderful. All right, someone I haven't heard from. What is a prime number? Go ahead. Okay, so these are examples. Good. So 7, 3, 2. What was the other one you said? It was like 5. Okay, so those are great examples. What is a prime number? Okay, so does this make sense to everyone? It's a number that's divided by only 1 in itself. So let's look at 7, for example. What are the factors of 7? 1 and 7. Are there any others? Okay, let's look at what's a number between 10 and 20 that's a prime number? 17. Let's look at that one. What are the factors of 17? Yes. 17 and 1. So the only factors for prime numbers are 1 and itself. Itself being the number, or x. Okay? So what I want you to do is we're going to find some simple ways to be able to find out if large numbers are prime numbers. Because you guys, for the most part, I would guess that you would be able to fill out a number chart up to 100, correct? And circle the numbers that are prime numbers. Pretty easy to figure out just by thinking about it. There are 2 or 3 tricks that we can use for huge numbers, that's in the thousands, millions, even hundreds, that'll help you understand whether a number is prime or not. The first trick is if you add the digits together. So if I write the number 711, and if I add these digits together, what does that equal? If that number that it equals is divisible by 3, that means that this number, 711, is divisible by 3. Okay, so looking at 711, you wouldn't know for sure if it's prime off the bat, would you? Usually? Not really. But since we added the digits together and that equals 9, and 9 is divisible by 3, we know that this number, even if it's divisible by nothing else, is divisible by 3. Does that make sense? Yeah, so give me a 2-digit number. So 98. Okay, so let's look at 98. If we add those two numbers together, what do they get? Is 17 divisible by 3? So we know that this number is not divisible by 3. It is divisible by something else. 2. Okay? Which is the next trick. You have to remember any number that's even. So what does the number have to end with if it is an even number? 4 or 0. Any number that ends in those digits is definitely divisible by 2. Okay, so we've got divisible by 3 by adding. We've got divisible by 2, whatever the last number is, so 2, 4, 6, or 8. And if a number has both of these, that also means, and we'll talk about this later, this is more complex, that also means it's divisible by 4. So let's try to find an example of one that actually might have written. Yes. So the number 912. Add up the numbers, and what do we get? Drew? And is 12 divisible by 3? Okay. So we know it's divisible by 3. Is it an even number? Okay, so we know it's divisible by 2. Which means that, what also do we know it's divisible by? 4. What's that? Sorry, I can't hear you. Yes, because 3 and 2 multiplied together is 6, which means that it can be broken down, factored by 6. Okay, and that's another complex thing that we'll get into in a little while, but that's awesome, right? Yes? Correct, if it's divisible by anything but 1 in itself, it's not prime. So if it's divisible by 2, 3, 4, 5, 6, any other number, it's not prime. So this would not be prime. 711 would not be prime. 912 would not be prime. What if it was 911? 911. Is that divisible by 2? No, so I'm going to put a 2. Is it divisible by 3? No. Which means it is divisible by 4?
How would you do that?
It's not divisible by 5 either, is it? What does it have to end in to be divisible by 5? 4 or 5. Okay, which means it's also not divisible by 6. I'm not sure about 7, so we have to check that. But looking at it right now, what would we say our guess is? It's a prime number. Okay? So what I want you to do right now, 3 practice things that I want you to do. The first one, I want you to write down, list 7 prime numbers that are greater than 100. 7 prime numbers that are greater than 100. And I'll leave this here. I'm going to read all the questions to you. So if you want to do the other ones first, because that one might take longer. The second question is, each child has 50 pieces of candy. If there are 6 children, how many pieces of candy are there in total? So remember, I want you with that to write these blank times blank equals blank, but then make your F's and P's. Okay? So the question again, each child has 50 pieces of candy. If there are 6 children, how many pieces of candy are there in total? And the last question is, Nancy has 9 boxes of bottle caps. Each box holds 50 bottle caps. How many bottle caps are in total? Okay, I'm going to give you, as a group, we've got about 6 minutes left, so I'm going to give you between 2 and 3 minutes to answer those questions.
Let's start with the
You done with the article? Okay, what's the next thing you're supposed to do now? Okay, then move on to prayer. You can start with this. Carter, are we following along here? Connor, are you writing a story right now? I hope not. Stick with your prayers. Yes, that is correct.